Welcome to Mimi's Math channel. Today I will evaluate determinants using 2x2 and 3x3 matrices. So let's go over what the actual formulas are. 2x2, as you can see, I have a row of 2's and a column of 2's. That's why it's called 2x2. And what I'm going to do is I'm going to diagonally multiply A times D, and then I'm going to subtract diagonally B times C. So that's what this means over here. Then I'm going to go down to my 3x3. Now that one's a little bit more complicated. So I tried to color code it, so hopefully that'll help you. So A, B, and C are going to be your scalars that are on the outside of your matrices. And so what I want to do is, if I chose A, I want to mark out everything that's in the same row and column, and then what's left over, I highlighted in the pink box. That's what's going to go on my 2x2 matrix. And then I'm going to do the same thing for B. So B is in green. Everything that's in the same row I'm going to get rid of, and everything in the same column I'm going to get rid of, and I'm left with everything that's in the green ovals. So you'll see that my scalar is showing as B. However, inside of the 2x2 matrices are D, F, and GI. Then finally, I would go to C, and everything that's in the same row and column, I would scratch out, and whatever is left over is going to go on my 2x2 matrices. And that's how you're going to start the process. And once you get this to this part, you would now go and use your 2x2 formula to evaluate. So this is what it's going to look like. Let's go ahead and start with example 1, which is the 2x2. We're asked to evaluate the determinant. So I'm going to multiply diagonally. I have -6 and -4. And once I multiply that out, that's going to be positive 24. And then I'm going to subtract that from 2 times 3, and that's positive 6. I'll go ahead and simplify that. 24 minus 6 is going to be the determinant of 18. So let's go to the next example, example 2. So the first thing I want to do is I want to recognize that the top row, these are going to be the numbers that are going to be outside of my 2x2 matrices. So I'm starting with 5. And for 5, I am going to have next to it, once I cross out what's in the same row and the same column, I'm left with 0, 2, -1, and -5. Now I'm going to go to -2. And I'm going to cross out what's in the same row and what's in the same column. And those numbers that are left over will actually go inside of my 2x2 matrices. Then finally, I'm going to add. So I didn't point that out earlier in the formula. What you'll notice is B is the second one I'm subtracting and the third one I'm adding. So watch out when you have like a negative times a negative, and make sure you change those signs if needed. So now for the last part is going to be 3. And then what's left over, so this is my 3. And what's left over once I remove the row and the column are 4, 0, 7, and -1. So that's what's going to go inside of my 2x2 matrices. Okay, now I have to use the information that I learned about the 2x2 determinants, which means that I'm now going to go diagonally, multiply that, subtract it from that product that's diagonally the other way. And then I'll go back and do my scalar multiplication. So 5 is going to still be on the outside. And I have 0 times -5, which is 0, minus 2 times -1, which is -2. Negative times -2 is positive 2. -5 times 4 is -20, minus 2 times 7, which is 14, plus 3. And then I have 4 times -1, which is -4, minus 7 times 0, which is just going to be 0. Now I want to simplify. I have 5, and then inside of the matrix, I have 0, and this is going to turn into a plus because a negative times a negative is positive. So 0 plus 2 is 2, plus 2, and then inside of the matrix, I have -20 plus -14, which is -34. And then finally, I have plus 3, and inside of the matrix, -4 minus 0 is -4. And now simplifying this down, I have 5 times 2 is 10. 2 times negative 34 is negative 68. And 3 times negative 4 is negative 12. Once I combine this information, I have negative 70 as my determinant for this 3x3 matrix. Thumbs up, like, and subscribe. Have an awesome day.
Subscribe.